Okay, so in the wild world of quantum computing, something just happened. A new kind of echo has been heard, and you know what it's telling us? It could literally change everything. Today, we're going to break down this huge breakthrough, what it means for science, for tech, and yeah, for the security of our entire digital lives. So, get this. Google's research team didn't kick things off with some crazy equation. Nope. They used this analogy. It really hits home, right? This isn't just about finding something new. It's about seeing our world with a kind of resolution we thought was just sci-fi. It's the difference between just guessing what's down there and truly knowing. So what's behind this massive leap? It's an algorithm they're calling quantum echoes. And you can basically think of it like this. It's a way to send out a little ping into the quantum world and then just listen with mind-blowing precision for the signal that bounces back. This is how we're finally starting to, hear the language of molecules, to understand how nature really works on the inside. And look, this isn't just some theoretical what-if speed boost. We're talking about a real calculation, done an incredible 13,000 times faster than the absolute best supercomputer we have. But, and this is the real kicker, the result can be checked. It's verifiable. That right there, that's what makes this a genuine quantum advantage, not just a party trick. Okay, so here's the core idea, and it's brilliant. It's kind of like a bat using echolocalization, right? But we're doing it at the quantum level. Scientists send in a signal, they poke the system just a little bit, a tiny control disturbance, and then they reverse the whole thing. It's like rewinding the tape. When they do that, the echo that comes back is super clear and amplified. It gives them this stunning, high-def picture of how a system works at its most fundamental level. All right, to really get why this echo is such a game changer, we got to take a quick detour. We need to step into the quantum realm and just touch on the super weird and powerful rules that make all of this stuff even possible. So, it all begins with this thing called a qubit. Just think of it as the superpowered cousin of the regular computer bit you already know. A normal bit, it's stuck. It's either a 0 or a 1. That's it. A qubit, though, it can be a 0, a 1, or somehow both at the very same time. And this spinning coin, it's the perfect way to picture that superpower. It's called superposition. You know how the coin isn't really heads or tails while it's spinning? It's both possibilities at once. A qubit is just like that. And that's the key. That's what lets a quantum computer check out a massive number of potential solutions, all at the exact same time. And just when you think it can't get any weirder, it does. Then you have entanglement. Seriously, imagine two qubits that are so connected that if you measure one, you instantly know the state of the other one, even if it's on the other side of the galaxy. Einstein himself called it spooky action at a distance, and that spooky connection is what lets them work together in these unbelievably powerful ways. So what does all this weirdness add up to? Well, the difference is huge. Think about it like this. A regular computer trying to solve a maze is like one person, walking down every single path, one after the other. It takes forever. A quantum computer, though, it's like sending a whole team to explore every single path in that maze simultaneously. It's a total game changer. But there's always a but, right? Here's the catch. All these quantum powers are incredibly fragile, like super fragile. For decades, the biggest problem has been just trying to control them. So now, let's meet the hero of our story, the hardware that's finally starting to tame all that quantum chaos. This is it. This is Willow. And it's a quantum chip designed for something much harder than just raw power. It's designed for control, for precision. You see, the biggest enemy of quantum computing has always been this thing called decoherence. The best way to think about it is like trying to hear a whisper during a hurricane. Even the tiniest little disturbance from the outside world can mess everything up and ruin the whole calculation. Willow, this chip, is a huge step forward in protecting these delicate states from that noise. It's tackling a problem that has honestly stumped scientists for 30 years. And with this newfound control, you unlock something amazing. Scientists are starting to call it a quantum scope, basically a tool to see the fundamental building blocks of reality. I mean, think about the possibilities. We could totally revolutionize drug discovery, design new materials for incredible batteries. We could even simulate some of the craziest things in the universe, like wormholes and black holes, for real. But this incredible power, it has a shadow side, a really serious one. Because a computer that's powerful enough to build all those amazing things, well, it's also powerful enough to break things. And the main thing it could break is the very foundation of our digital world, encryption.
So why is that? Well, it turns out that the exact same quantum magic that makes these computers perfect for solving super complex problems, like figuring out new drugs, also makes them dangerously good at solving the complex math problems that our encryption is built on. A big enough quantum computer could just shatter the codes that protect everything: your bank account, your private messages, even national secrets. And this has created this silent ticking time bomb. There's a strategy that security experts are really worried about. It's called Harvest Now, Decrypt Later. Basically, bad actors are stealing huge amounts of encrypted data right now. They can't read it today, but they're just hoarding it, storing it away, and waiting for the day when a quantum computer can give them the key to unlock every last bit of it. And just to be super clear, this is not some far-off science fiction problem. This is happening now. The data being stolen today is what's at risk tomorrow. The entire foundation of trust on the internet is at stake, and the tool to break it isn't even fully built yet. That's how serious this is.
So, all of this brings us to where we are right now. We're at this critical moment defined by two huge parallel races against time. And what's wild is that they were both started by the exact same technology. On one hand, you've got the race to build. That's labs all over the world pushing like crazy to create a big, stable quantum computer that can deliver on all this incredible promise. And on the other hand, you've got the race to defend. That's all the cryptographers and security folks scrambling to create brand new kinds of encryption that a quantum computer just can't crack. So the new buzzword in cybersecurity is something called crypto agility. All it really means is that we have to build our digital systems to be more flexible. We need to be able to quickly swap out our old, vulnerable encryption for new, quantum-safe ones as soon as they're ready. And we have to do it without, the whole internet crashing down around us. So that Quantum Echoes experiment, it sent us a pretty clear signal. A future with this kind of mind-bending computer power, it's not a question of if anymore. It's just when. And it's bringing with it these incredible opportunities, but also these massive, unprecedented risks. We've heard the echo from the future. The only question left is, are we ready for what it's saying?